going to have a look at the PLCs that are used in the fourth year electrical apprentice course. And we're going to take a look at, in particular, the communication setups for them. They can be a little bit tricky. So we're going to zoom in here and have a look at the actual hardware. The hardware is mounted on a piece of plywood. It contains everything that is needed to do the labs. At the bottom we see the PLC itself with an expansion module that's been attached to it. Beside it we have the 120 volt input power supply in a 4-inch square box with a printout of the I/O configuration. That's the input and output addresses. The large gray box, of course, is the actual field hardware. Things like push buttons, stop and start, handoff auto, momentary push button, toggle switches, and the outputs will be represented by lights, 3 contactors, and there's a real wimpy little horn type affair inside of it. So what I'm going to do to begin with is I'm just going to take a moment and I'm going to hook this up. And what I'm going to ask my lovely cameraman to do is to focus in on the PLC LCD screen, get right over top of it, and you'll see the self-diagnostic that takes place when it's first powered up. So I'm going to do that now. All right, the self-diagnostic is complete, and we can see that the PLC is now up and running. It is in run mode, and the screen that is being shown is the status of the inputs and outputs. At the top you see a bunch of little boxes that are either shaded black or open white, and that tells me that their inputs are either on or off. I'll press a start button and see if you can tell the difference. Start button on, start button off. Start button on, start button off. I'll try the toggle switch. Toggle switch on, toggle switch off. Momentary contact, on, off. All right, so we're good to go. The PLC is up, it's running, it's in the run mode. I'd like to have a look at some of the communication cables. Because what we're going to do is we're going to hook this device, the PLC, up to this computer here, and we're going to be doing some programming and changing how the PLC behaves. But in order to do that, we have to communicate between the PLC and the computer. Okay, if we could have a look on the side, and we'll introduce to the 2 communication ports right over here, Dave. Okay, so I have 2 communication ports. I have an Ethernet port here, which we're not going to tackle. I mean, we certainly could, but we just get congestion on the network. This is a serial port, and this is the port that we will use. Okay? Have a look at the desk in front of the next computer station, and you'll see 4 different cables. All of the cables have the serial end connection. This is the end that goes into the PLC. If you look closely, and I'm not sure how good the camera is, but there's an actual arrow embossed in the plastic, and that arrow goes to the top when you plug it in. Okay, we were talking about the serial connection that goes to the PLC. These connections are what they call keyed, meaning they can only go in one way, and that's where the arrow comes in to help us. The arrow is pointing, it's up when you insert it into the PLC. All right, now this cable has a different end on it. This end goes into a computer, but this is a rather old style serial port, and many computers no longer have these. Luckily, ours do, but perhaps the next time they refresh this lab, the computers won't have this, and we're going to have to find another option. That's where these computer cables come in. Again, we see the serial end that goes into the PLC, but this time the other end is much more familiar. This is a USB end, and it fits into any common USB port. We've used these for about 4 years perhaps, and we have 3 different versions of this serial to USB conversion. This black unidentified box is version 1. It's very glitchy and tends to lose communication regularly, so we're not going to be using this. If you see one of the PLCs that is using this particular cable, just take it away, replace it with a newer one, and you'll have less problems. This is the second version of the PLC. Again, serial to USB, but this time it's labeled. And you can see that it actually has a date on it. The date in this particular case is 2015. This cable is better than the first one, but we found that we still get drops on this. Occasionally, when we're communicating with the PLC, it'll just lose communications. We're not really sure what's causing it. We think it could be a driver issue, but it's just something that we've had to deal with. We bought a whole bunch of brand new model serial to USB cables. They look identical to the last ones. Again, the serial PLC to the USB. Again, printing on the little box, but this time, of course, we see 2017. This is the preferred cable, the 2017 USB to serial connection. So we're going to give that a go. I'm going to plug it in, and then we're going to see how to set it up to communicate with the computer. So just come on over here and we'll see just how easy this is. I'm making sure that the, boy, I say a lot, eh?
I can edit that out.
This one is very hard to see the arrow, but I can see it. I'm going to ensure that it is facing upwards when I insert it into the serial port. Be very gentle. Those pins will easily bend and pretty well render the cable useless. One end is done. I'm going to put the other end into a USB port on my computer. There are 2 programs that we use when we're programming PLCs. One program is strictly used for communicating to make sure that we're talking to the PLC. However, before we do any work on either of those 2 programs, I have to go into Windows and do a little investigating. So I'm going to go into Start and Control Panel, and then I'm going to find Device Manager, or Devices, or Device Manager. That's what I'm after. It gives me a warning that I'm not an administrator and I can't make changes. Well, that's okay. I don't want to make any changes. I just want to see something. This is Device Manager. I'll make it big. So this is the information I'm looking for is in ports labeled COM and LPT. If I click in front of that, I'm going to see right here USB serial CH340. I'm going to make that bigger if I can. I'm not sure if I can zoom that up for you. I'm afraid I can't.
I think I got it.
You think you got it? All right. In this case, it says USB serial CH340. That's the information I need. It says COM6. I need to know what COM port it's on. So I had to come into Device Manager, and I've learned that I'm going to communicate on COM port 6. That's all I need Device Manager for. I can close it. Now I'm going to have a look at those two programs. I go into all programs, I go to Rockwell software, I'll click in there, and the two programs I'm interested in are RS Links and RS Logix Micro. RS Links, that's the communication software that links the computer to the PLC. I'm going to start that program, RS Links Classic. All right, I'm taking a look at a typical screen. It may or may not come as it's shown here. If this program starts with nothing but a gray screen that looks like this, all you have to do is go to Communications and click on the very first option, RS Who. That will give us that same information window. I'm going to make it big. Wonder if I can make this larger. No. What I'm going to do is I'm going to click on the DF1, Delta Foxtrot 1. That's our driver. That's where my PLC should be. I should be seeing something there. And indeed, I'm seeing that the Micrologix 1100 is connected there. But there's a red X in front of it. So I have to get rid of the red X. The red X tells me, of course, that it's not communicating yet. Simply click on it to highlight, then right-click, and select Configure Driver. Here is where we change the COM port. The reason it's not communicating is because this is set to COM port 1. I need to change that to COM port 6. Click the drop-down box, scroll down, there's COM 6. Make sure that you've selected the proper COM port, and there's just one thing left to do, and that's click the Auto Configure button right here, the Auto Configure button.
And it's not necessarily always going to be COM port 6, am I right?
Oh no, that's the problem. The whole problem with this communication is the COM port changes. So if I unplug it from this computer and plug it into another computer, that other computer will put it on COM 8, or another one will put it on COM 5. So I have to always know the COM port before I come in here to change it in the RS Links. In this case, I get a readout that says auto configuration successful. There is one peculiarity with this program, and that is occasionally I'll hit auto configuration and it'll come up with an error screen. Get rid of the error screen, and behind it you'll see that it'll say auto configuration successful. It seems to be a glitch in the programming of the software itself. But all I'm after now is this printout, auto configuration successful. I'll click OK, and just wait a moment, and the X disappears. The X is now off of the Micrologix. The PLC and the computer are now connected and talking to each other. I'm going to minimize this. I could close it, there's no problem with closing it, but I'm just going to minimize it in case I need to get back in. And we'll now have a look at the second piece of Rockwell software, and that's the programming software. It's called RS Logix Micro. So we go into all programs, and again we go to Rockwell software, RS Logix Micro, English. We don't have the French version. And I'll click on that. And we're presented with this screen. It is a blank slate. We have no program yet to manipulate. There's two things we can do. We can start a new program and start building a new program, or we can have a look at what's already in here. A student has been programming on this, and there is a program in here. It's kind of cool to have a look and see what the last class has done. So what I'm going to do is I'm going to take a look at the program that is running in this PLC right now. And in order to do that, I go up into comms. There's a tab right at the very top called comms. And the option I have is upload. All right, that's the only option I have. I'm either going to download into a PLC or I'm going to upload from a PLC. Those are the two ways I can communicate. Right now I don't have anything built, so the only option I have is to actually upload from the PLC. I'm going to give that a try. You just click the box that says create a new file, and the uploading takes place. And there's a box that asks if you want to go online, and you can click yes or no. And you can scroll through this program and take a look at some of the work that the previous student has done. There appears to be a lot of timers here. Actually, there's quite a few timers here. You could possibly run this program if you wish, but that's getting a little bit ahead of ourselves. Anyway, it's just kind of cool to look at what some of the other people have done. What I'm going to do now is I'm going to start a new file and a new program, a new project for us to build. And all you do in typical Windows fashion is go File, New, and it's going to ask me if we want to close this existing file, and of course we're going to say yes to that. We're not going to save any changes to it. And we're presented with this box, and this is a very important box. This tells the program what PLC we have. This software can work with a bunch of different PLCs, but we have to know which one we're programming for. We're programming for the very first option, which is an 1100 Series B. So there's no need to change anything here. Just click OK. That looks a lot better. Now we've got a blank white space here where we can build our program. But we're not quite done yet. We're not quite done telling the computer about our PLC. We have to tell our computer that not only do we have a PLC, we actually have an expansion module as well. So I have to tell the computer about this expansion module. And I'm going to do that by going to, on the left-hand column, something called IO config. This makes sense because the expansion module is an additional output. So I'm going to double-click that. If you read on the side of the expansion module, you'll see that this is a 1762 OW8. You can make that selection on the right-hand side here, and I'll highlight it. And there it is. And all I have to do is double-click, and it'll move that over onto my PLC. This is my PLC here. These are the available expansion modules. I'm going to double-click. And now you'll see that I have my Micrologix 1100 Series B and an 8-output relay expansion module OW8. This is good. We're done with that. I can just X out of it. All right, this is quite a procedure, but believe it or not, it will get to become second nature. You'll be doing it fairly regularly. We'll do a really, really simple program on the screen here, and we will then download it into the PLC. We'll take a look at how it works, and from that point on, you can work on your own projects. Okay, we are going to make our first simple program. We're going to take a look at the software, and at the top of the software we're going to see some familiar symbols. We have our examine on, our examine off, and our output energized. That's right at the very beginning of this software under the User tab. All I have to do is highlight the rung. So I'm going to highlight the rung in red, and then I'm going to start clicking on the devices I want. I'm going to click and it'll insert automatically my first examine on. Now this is where it gets really, really easy to manipulate. The next contact you're going to bring in, click and drag it. Don't just click, but click and drag it. And you'll see some red boxes show up. You can drag it around to wherever the red box turns green. So I've now turned the red box green. I'm going to let it go. And I now have two of those instructions, both examine on. And I'm going to actually just do a little stop-start station here. So I need a branching circuit, and right to the left of the examine on is the branching circuit. So I'm going to click and drag that. And again, bring it to a place until it turns green, and you'll see that it's not doing me any good here. But I do have a rung that's highlighted, so I'm going to click and drag that and bring it over until it turns green, and now I have my branched instruction around this examine on. What do I do now? I go back up, click another examine on, drag it down, and I can put it anywhere. I've got a lot of options. I'm going to put it down in the bottom rung. It's turned green. And I now have my stop, start, holding contact configured in software. I still have to put in an output energized, but that's relatively simple. I'll click, hold, drag, and if I put it here where it's turned green, it's probably going to snap to the end anyway, because a coil or an output energized must be the last item on the line. And it did. It went all the way to the end. So what's left to do with this is I have to give some addresses to this. If I tried to run this program, it wouldn't even allow me to download it because it doesn't know what the addresses are. So I'm going to start inputting addresses. There's a little question mark above each of these instructions. I'm going to double click on the question mark. And this is an input, so I'm going to look over here on my input diagram here, and my stop button is input 0/0. So that's the address I'm going to put here. Now please pay attention, because it's critical that you put it in this way, or else you'll get an error. So what I'm going to do is I'm going to go I, Shift, colon. So this is not a semicolon. A semicolon will give you an error. I have to have the two dots, not the dot and comma. So that's a colon. This is what I've got. I've got I, colon, 0/0. That is an address for the stop button. I, colon, 0/0. And you can see them. They're listed and detailed on the I/O sheet on the PLC backboard. So you can get any address you want off of this roadmap. So I'm going to take a look for a start button. And the first start button is input 0/1. So I'm going to now put that over my start button. There's an annoying little feature here. When I hit enter after I've inputted an address, I get this description box. What I can actually do here is I can actually put a label on this. So that's what I'll do. I'm going to put stop and click OK. And now if you take a look at the screen, not only will you see the address, but you'll see that this is a stop button. Okay, I'll do the next one a bit more quickly. I'm going to put input 0/2. That's the first start button that's available. 2. And I'm going to hit enter, and I'll put START. That'll indicate that this is my start button. Good. And we're good to go. And now I'm going to go all the way to the end rung, all the way down here, and I'm going to put in my first output instruction. Now I want to be dramatic because, well, people like to be dramatic. You know, lights are nice, but I like to hear noise. I'm going to make a contactor energize here. So I'm going to take a look at my first contactor address, and it is output 1/3. So that's what I'm going to enter in here. Output : 1/3. Hit enter, and I can call this what I want. Perhaps this will be motor 1. So now I have a stop, a start, and motor 1. Now in motor control, you're used to using a holding contact to seal in the operation of a stop-start station. But in PLCs, we don't need a dedicated holding contact. We can actually use the output of this, or we can use the output energize instruction itself as the holding contact. Let me show you what I mean. I'm going to address this output : 1/3. I'll hit enter, and you'll see that motor 1 output is going to form the holding contact for my stop start. I think I've got it. I think this is a good, valid program. But before I do anything, I have to verify that there's no errors because, well, everybody does make errors. And up at the top, you're going to see...
You've never made an error. Come on.
Well, no. Other people make errors.
Okay, thanks.
Other people do. So I'm pointing out here that there's, right in the middle, there's a little blue check mark. The little blue check mark is what I'm going to press, and it'll scan my program and inform me if I have any errors. And down here at the bottom, it says verify has completed, no errors found. I want to show you an error, so I'll deliberately place an error in this program. I'm going to grab an instruction, I'll place it, and I won't address it. That should be an error, so I'll go back up and I'll try to verify. Now you'll see at the bottom a box has opened, and it tells me that rung 0, instruction 7, error. It says the operation has not been entered. We have to enter something for this instruction. So the software will tell you if you have your program done right or if you've got errors in your programming. Right now I'll just delete that because of course I don't need it to run. All right, we're ready to go. I now want to get this program into the PLC. If you remember, when we wanted to go from PLC to computer, we uploaded. Well, what we want to do now is we want to download into the PLC. If you remember, we went to comms, and the only option I had was to upload. But if you notice now, I do have the download option. So that's what I'm going to select. Okay. It's going to ask me to save my project with a file name. You should always do this. I'll just call it basic stop start. Remember where you save it. I save it to the desktop, but it does tend to get a little cluttered. But at least I know where everything is. So I'm going to save it to the desktop. All right. Now it's asking me, are you sure? Do I want to take this and bring it down and download it into that computer? Yes, that's exactly what I want to do. But now it gives me an error. It says the processor is in run mode. this software will not download a program into a PLC that's already running. So I have to change that mode. And if we'll just pause for a second, the camera will go back to the PLC and we'll take a look at how to change that. All right, we're looking at the LCD screen on the PLC. We have to change the mode. The very first thing we have to do is escape from this screen. This is the I/O screen. I hit escape once. Notice I have some selections here. I now want to go into the third selection down, 1, 2, which is mode. And here you can see that the arrow is pointing to run. I have to get the arrow off of that, so I'm going to cursor up twice, 1, 2, and I'm in program mode. Okay, so now this PLC is ready to accept a new program. All right, the error screen here says the processor's in run mode. I click OK, but I've taken it out of run mode. My program is now downloaded into the PLC. It's asking me if I want to go online, and yes, of course I do. But what I have to do now is I have to go back to the PLC and put it back into run mode to see how my program operates. So pause and we'll do that. All right, all I have to do is 2 cursors down, 1, 2, and hit OK. And my PLC is now in run mode. So let's pause and come back to the screen and we'll see something that has appeared. All right, we now have the side rails are highlighted in green and our first instruction is also highlighted in green. And it should be, because this is a stop button. It's normally closed, so I'm examining if this is on and this input is on. So now what I should do is I should go over and press the start button, and I will have a look and see what the see how the highlighting changes here. And then of course I expect the output to energize, which will in turn seal itself in. I'll hold the stop button down for 3 seconds and we'll see if that takes place. I'm going to try to get past the camera. All right, here we go. I'm going to press the start button, hold it for 3 seconds. 1, 2, 3. You'll notice the start button is no longer showing that it has been closed, but the program has sealed itself in since the output has energized, and I can use that information to seal in a basic stop-start circuit. Okay, earlier we talked about verifying our program for errors. There is one error that seems to slip through, and it's a mistake that students will make without really deliberately intending to. And I'm going to briefly show you what I mean. I'm going to put another rung in with a simple examine on and another output energize. I'll address the input to the second start button. So that'll be input : 0/3. But this time I'm going to take the output to the same as the one above it. So I'm going to use the same address twice. Output : 1/3. All right, I'm going to verify it for errors. So I'll press the green check mark, or there it is, and it shows that there are no errors. I'm going to download this into the PLC. So that's comms download. If you'd like to make a note about the revision, you could perhaps put a revision note in here, added rung number 1, if you'd like to keep track of your changes. And it's going to ask me if I want to download. Of course I do. And the download is underway. It doesn't take long. Yes, I want to go online. And now I have to put it back into run mode. So I'm going to go to the PLC and quickly do that. You'll notice run mode because the side rails turn green and the stop button is showing that, yes, the stop button is still closed, so I do have an on signal. But once again, I just want to show you this error. I've got the same output address, all right? So I'm going to come back here and I'm going to press the second start button. That works great. I'm going to go back and press the first start button. I have to stop. I've now lost communications to the PLC. You may remember I mentioned that these cables can be a little finicky. Well, we've just encountered that. This is the error that you'll see. So what I'm going to do is I'm going to go offline. I'm going to go back to RS links, and you'll notice the red X is back. That's quite annoying. But all we have to do is highlight the blue box, right-click, configure driver, and auto-configure again. Once again, it shows it's successful. Click OK. The red X is gone, and it'll be communicating. Oh, I have to put it in run mode. It is in run mode, so I'm going to go online. There we go. Again, we're demonstrating a common error condition that students inadvertently make. They'll take this same address and try to energize the coil using two different rungs. This is not functional in this software. Again, second button works. First button, nada. Stop button is off. The program has failed. There is no control on that output anymore. So to re-summarize, when you're making your programs, please do not use the same address more than once as an output. You'll just run into all kinds of errors. If you need that output on more than one rung, we'll use our control relay trick. So we could use our first rung as a control relay and then multiple points of contact from that control relay in various rungs. That's probably the easiest way to overcome this. Other than that, I think that pretty well covers this particular error that you might encounter. This is basic introduction to PLCs. We've learned about the communication cables that are used, and I made the suggestion to get the most recent one, get the one that's 2017. However, if you have connection problems, the one thing that we can do is we can fall back on that very, very early version, the one with that long serial port, which is this one. This one never drops out. However, we're trying to phase them out because, well, our next computers just won't have this port. So good luck with your communications and good luck with your programming. We always find this to be probably one of the most enjoyable parts of fourth year. We have a lot of fun with it, and I'm sure that you will too. Have fun.